Greetings, fellow space enthusiasts. Today, we embark on a journey through the cosmos, exploring the mysteries of our solar system. Thank you for joining me on this cosmic adventure. Together, we'll delve into the fascinating question that has intrigued scientists and dreamers alike. What if Jupiter, the giant of our solar system, had become a star? Imagine the night sky with two suns, and how different our world might be. Jupiter, with its swirling clouds and colossal size, has often been dubbed a failed star. Its immense presence and dynamic atmosphere captivate our imagination. It's easy to see why. The Great Red Spot alone is a storm larger than Earth, raging for centuries. Jupiter is massive, composed mostly of hydrogen and helium, just like our Sun. These elements are the building blocks of stars. It even emits more heat than it receives from the Sun, a trait that hints at its stellar potential. However, don't let these facts fool you. Despite its impressive attributes, Jupiter lacks the necessary mass to ignite nuclear fusion. Jupiter, despite its impressive attributes, falls short of the stellar mark. It remains a majestic gas giant, not a star. To ignite the fires of nuclear fusion and become a true star, Jupiter would need a dramatic increase in mass, about 80 times its current heft. Only then could it shine as a star in the vast expanse of space. Star formation is a fascinating process, a cosmic ballet of gravity, pressure, and heat. It's a dance that takes place over millions of years, hidden from our eyes but revealed through the lens of powerful telescopes. It all begins with a giant cloud of gas and dust, a nebula, drifting through the vast expanse of space. These clouds are the birthplaces of stars, where the raw materials for stellar creation are gathered. Gravity, the architect of the cosmos, draws these particles together. Over time, the gravitational pull becomes stronger, pulling more and more material into a dense core. As the cloud collapses, it spins faster and faster, like a figure skater pulling in their arms. This increase in rotation helps to flatten the cloud into a disk, with the core at its center. The temperature at the center rises dramatically. As the core contracts, the pressure and temperature soar, setting the stage for the next critical phase. When the core reaches a scorching 10 million degrees Celsius, the magic happens. Nuclear fusion ignites. This is the process that powers stars, converting hydrogen into helium and releasing vast amounts of energy. Hydrogen atoms, under immense pressure, fuse to form helium, releasing a tremendous amount of energy. This energy radiates outward, balancing the gravitational forces, pulling the star inward. This is the moment a star is born, bursting into radiant light. The newborn star shines brightly, a beacon of creation in the cosmos. Sadly, for Jupiter, this was a threshold it could never cross. Despite its massive size, it lacked the necessary mass to ignite nuclear fusion and become a star. Imagine a vast dark cloud of gas and dust, a cosmic womb where stars are born. These are stellar nurseries, and they are scattered throughout our galaxy. Within these nurseries, gravity works its magic, pulling together clumps of gas and dust. As these clumps collapse, they heat up and begin to spin. The spinning creates a disk of material around the central protostar, a baby star in the making. Over millions of years, the protostar continues to gather material, growing larger and hotter. Finally, the core of the protostar reaches the critical temperature and pressure needed for nuclear fusion. The protostar bursts into life, becoming a true star. Section 4. Jupiter, the star. A new dawn for our solar system. Now let's indulge in a thought experiment. What if Jupiter had somehow managed to gather enough mass to ignite nuclear fusion? Our solar system would be a dramatically different place. With Jupiter radiating its own light and heat, it would cast a warm, reddish glow across the solar system. The night sky would be adorned with two suns, a dazzling celestial spectacle. The orbits of the planets would be altered, with some planets potentially being ejected from the solar system altogether. Earth's orbit, too, would be affected, potentially shifting us out of the habitable zone. Section 5. Moons in the spotlight, the hunt for habitable worlds. Jupiter's moons, those icy worlds with hidden oceans, would experience a dramatic transformation. Bathed in the warmth of a second sun, their icy surfaces would melt, potentially creating vast watery worlds. Europa, with its subsurface ocean, would become a prime candidate for life. Ganymede, the largest moon in our solar system, could also harbor life in its newly formed oceans. These moons, once locked in an icy grip, would become watery havens teeming with possibilities. Section 6. Life finds a way, or does it? In this section, we delve into the fascinating possibilities of life beyond our planet, specifically focusing on the moons of Jupiter. The possibility of life arising on these transformed moons is a tantalizing thought. Europa and Ganymede, with their icy crusts and subsurface oceans, present some of the most intriguing environments in our solar system. With liquid water, a source of energy from Jupiter's star, and a rich cocktail of organic molecules, the conditions could be ripe for life to emerge. Imagine the potential for microbial life forms thriving in the dark, cold oceans beneath the ice. Perhaps in this alternate reality, life would find a foothold on Europa or Ganymede, evolving and adapting to the unique conditions of a binary star system. These moons could host ecosystems unlike anything we've ever seen, with life forms that are uniquely adapted to their harsh environments. While we can only speculate about the possibilities, the search for life beyond Earth continues to captivate our imaginations. Scientists and astronomers are constantly exploring these moons, using advanced technology to search for signs of life. Thank you for joining me on this cosmic journey. The universe is vast and full of mysteries, and who knows what we might discover next. If you enjoyed this exploration of Jupiter's potential stardom, be sure to subscribe for more mind-blowing astrophysics adventures. Your curiosity fuels our journey through the cosmos. And remember, in space, no one can hear you scream, except maybe your dog, because they have really good hearing. Keep looking up and stay curious.